Hey guys, welcome back to another video. So here we're going to be looking at the transformation of functions. So, uh, so this is mostly helpful for sketching graphs. So I've made a couple of videos based on sketching graphs. I'll link all of them in the description below. The first video was about sketching the different types of graphs which are commonly asked in the IB paper, and then the second video was more specifically about rational functions, which is one of the more like difficult questions which they ask with regards to sketching graphs. And the third is a subset of rational functions, which are reciprocal functions in the form of 1, where they give you a function f of x and ask you to sketch 1 over f of x. So all those 3 videos are incredibly useful, and I recommend you watch those before coming to this. So these rules I've written here are basically quite self-explanatory. So if you're given a function y is equal to f of x and they ask you to sketch y is equal to f of x plus a, well, basically you just need to translate it. So the 3 types of transformations we are required to learn is translation, which is basically moving a function which is supposed like this to this, or this is horizontal translation. There's also vertical translation, which is moving a function. So there's also vertical translation, which is something like this. So translation is just moving the entire function either horizontally or vertically or both. So when do you horizontally translate a function? When you get the term f of x plus a, you horizontally translate the function by negative a units. So for example, if x plus over here, you have to remember that in the case of vectors, if it's positive a in the column vector here, you move to the right, and if it's like negative a, you move to the left. And likewise in the column vector here, if it's positive a, you move upwards, and negative a, you move downwards. So if they give f of x plus a, well, you move a units to the left, which is negative a. And if they give f of x minus a, well, you move a units to the right. And so that's quite self-explanatory. If you guys want an example, well, this, and then y is equal to 3x plus 2 plus 5. So you basically simplify the function. That would be, which is equal to 3x plus 11. So that would be nothing but, from sketching the function, it would be something like that, where this is 11 instead of 5. You just basically, you just shifted the function by 2 units to your left, and this would automatically change the y-intercept as well. I know this looks a bit like vertical translation, but it is not. It is actually horizontal translation. In linear functions, it's often hard to see. Now we're going to be looking at vertical translation, and yeah, that's quite self-explanatory. So you just basically move it by by a units, upwards or downwards. So over here, positive means upwards. So there's no like change in sign, unlike horizontal translation. So upwards is positive and downwards is negative. So now we can just let me give you an example. Let's take the same example. So y is equal to 3x plus 5. Now I want to translate it by 2 units upwards. So that would be nothing but 3x plus 5 plus 2, just adding 2 units to the whole thing. So that would be 3x plus 7. And so the graph would look something like this is 7. So it's basically the same thing with just a higher y-intercept. So in this case, why the y-intercept change is basically, just look at it like you're pulling the graph this way, so that the 5 term goes lower, and then the 11 term comes down lower as well, and that's why 11 becomes the new y-intercept. So yeah, so the first 2 translations are quite self-explanatory. Now let's look at reflection. So reflection is again quite simple. Over the x-axis, so reflection over the x-axis, if you have a function like this, take x-axis as a line of symmetry and just reflect it. So yeah, and then reflection over the y-axis would be, if you have a function like that, you reflect it over the y-axis, so that the y-axis is the line of symmetry. So now we can take an example of y is equal to e power x, and y is equal to e power x would look something like that. The positioning depends on the y-intercept and whatnot. So let's just take it something like that. And y is equal to uh, e power negative x would be, since this would be reflection over the y-axis because it's an f of negative x. So that would be nothing but this would be e power negative x, and then y is equal to negative e power x would be nothing but, well, reflection over the x-axis. So as you can see, there's a negative sign added in front of the whole f of x equation, and therefore we're reflecting it. So reflection is all here. Dilation might look a bit tricky, but it is quite simple as well. So basically, just remember it as you take a function and then you're multiplying it by a constant, and you're basically blowing up the size and reducing the size by a specific factor. And what you should know is, in the key difference here is, when performing horizontal dilation, the factor is 1 over k. It is not directly k. And in the case of vertical dilation, we're stretching the values by k. So let's take a function. So let's take the function y is equal to e power x. Now let us do vertical dilation first. So y is equal to 2 e power x would be nothing but, well, you take each y value and multiply it by 2. In the case of e power x, it's not a very noticeable change. So if this was 1, well, the y-intercept will be 2. And if this point was, let's say, 5, this point will be 10. And likewise, you basically multiply each y value by 2. But how about e power 2x? How would you sketch that? Well, each x value would then become 1 over 2 into the original x value. So basically, if we take the original function and then at this point, in the intercept still stays the same, because if x is equal to 0, well, 2 into 0 is still 0 and y is still equal to 1. But otherwise, if y was equal to 5 for x is equal to 1, for x is equal to, the new x term will become x is equal to 5 over 2, and likewise all the other x terms will be divided by the scale factor, which was 2. So I think we now understand all the different transformations. They're actually super simple, but the complicated part about this is the order at which you perform transformations. Most of the time, IB is not going to be giving you simple transformations whereby there's only one of the different translations, reflection and dilation. Instead, it's going to be a complex combination of them. So for example, if they ask you to sketch 5, let me get a different color, 5 sine x plus 2 plus 3. So if they ask you to sketch something like this, well, first of all, you need to know the shape of trigonometric functions, which I did not cover in the first video, but so it's covered under trigonometry. So I hope you guys know the shape. It's very simple. It's basically something like that. And this is sine x. So yeah, the first step is to sketch sine x, and to know the shape, well, maybe extend a bit. It's very messy, but just keep that. It's just supposed to be a rough sketch. So we need to know if we were to individually perform the transformations, well, we can do that. But the key thing we need to do is to find the order at which we perform the transformations. So how do we decide the order? Well, basically you have to discern it. We have to derive it. So the function which this is based on is sine x. So if you were to, what steps would you take to make sine x into 5 sine x plus 2 whole plus 3? So basically what you can do is, basically you start from inside the bracket, or basically manipulating the x terms directly, or you start from outside, which is manipulating the whole f of x. So the first route, we'll take the first route for now. So we'll start by manipulating the x terms. So you can go either route. So the first step I would do is take sine x plus 2. So basically that would mean I So that means I horizontally translate it by -2 units. So it would be something like -2 shifts 2 units to the left. Well, now that we have manipulated the x terms directly, now we can actually go about solving the we can actually go about manipulating the outside, manipulating the whole f of x. So that would be something like, so there's two things which are being done here, which is, one is the vertical translation and um, the other is vertical dilation. So which one do we do first? You could either do this, first, and then in the next step add 3, or you could do something like, you can over here, if you add 3 directly and then multiply the whole thing by 5, well, you would get 15 instead of 3, which is supposed to get. So we cannot add 3 first. Instead, we could do something like, we could add 3 over 5 and then multiply the whole thing by 5, well, we get 3. So these are two different ways you can do the same outcome. So I prefer the first one because it does not involve any, because we're dealing completely with whole numbers. So let me show you guys how the first one works. So we're basically vertically dilating it by 5 units. So if point was, say, 1, well, now the maximum point would be, now the maximum point, these are just arbitrary values, just to be clear. So the maximum value would be something like 5, and this would still be -2, and this would be -5. So yeah, both the maximum and the minimum points, all the points get multiplied by 5. And then the next step would be to add 3 units. And this is a vertical translation. So in the final step, the graph will look something like, at -2, since we're adding 3 units, it's no longer 0. So it's something over here, and this would be 3. So this would be the minimum point, and then the maximum point, graph is very rough, so the maximum point would be 8 because we're adding 3, and then the minimum point will be -2, would be the final graph. So I hope you guys understand how the order of transformations works. So basically every single time you have to derive it, just remember that you start either from the outside or from the inside. So you could, by outside I mean manipulating the f of x function as a whole, and by inside I mean manipulating the actual x variable only, which is like what, horizontal translation, reflection over y-axis, and horizontal dilation. So yeah, you could start with that or the other way around, but remember, only after completing the whole outside you can go into the inside, and only if you complete the whole inside you can go into the outside. So that's basically how I approach transformations, and I hope this has been helpful, and hopefully this helps you save a lot of time. If you guys want me to use the rules of transformations on other types of functions, leave a comment below and I'll definitely make a video for it. Thanks for watching.